Thanks for coming. It's a great conference till now. Did you find the talks interesting? Yeah. You've seen a lot of interesting stuff here, and we promise we will not talk about AI. No, I am just kidding. So there will be also AI in this presentation. We will talk about e-commerce use cases with OpenSearch. Okay, so I'm Lucian. I'm here with my colleague Amine, and we are from France, from a company called Adilian. We do consulting services around OpenSearch, Elasticsearch, Solr, and we also have a e-commerce vertical on top of Apache Lucene, which also works with OpenSearch. Yeah, so just as an introduction, you have maybe noticed that there are a lot of verticals on top of OpenSearch. Yeah, so the one that's maybe the most advanced is the observability one, because you have OpenSearch dashboards, you have the AI assistant, you have plenty of stuff. You have data prepper around observability, so you have a vertical on top of that. There isn't actually a e-commerce vertical on top of OpenSearch. So OpenSearch is a technology, is a cool technology that offers APIs and specific features that you can use for e-commerce, but there isn't, so to speak, a vertical on e-commerce. There are, in the OpenSearch documentation, there are some features that are advertised as e-commerce features. Yeah, so the documentation is kind of poor. It's not only this, actually, as we will show, but we will speak about these features.
So why for e-commerce? Because in e-commerce you have several specific needs. For example, you have the search, of course, for products, but you also have autocomplete. You also need, for example, faceted search. You also need to provide navigation in your website or in your app. You also have custom relevance, for example, because what is relevant for the keyword search or vector search is not really relevant for the business or for the customers. You have to do a lot of merchandising and improve the business.
There are a lot of specific needs for e-commerce, as you saw, and there are also some additional needs in specific use cases. So you have e-commerce and e-commerce. So in this example, we have a customer that's in the retail business with groceries and all that, and you have some additional. So on top of these features that are needed for e-commerce in general, you might have also heterogeneous data, like in marketplaces, and also like physical stores that add some complexity on top of that.
So, of course, you have search and autocomplete services, but you also need to provide another search services in the platform. For example, deduplication. If we have a marketplace, so we have a lot of products that are coming for several providers, but it's the same product, so you have to do the duplication. And you have also to provide suggestions, similar products, navigation, of course, as we said, and products details for the page of products. So.
Yeah, so as we said, there aren't any like verticals that exist, but yeah, we cannot talk about e-commerce without talking about Chorus. Who knows Chorus here in the audience? Yeah, not many. So Chorus is kind of a set of tools that's initially built on top of Solr. The one with the OpenSearch is not that as complete as the Solr one, but yeah, it exists. So it's a first initiative for e-commerce, but. What we will show actually goes a lot further, and we will show the architecture of our product, which is a vertical on OpenSearch for e-commerce. And we will not necessarily talk about architecture and what we build around OpenSearch, but what specific OpenSearch features and APIs we have used and how we have used them. In the architecture, in the global architecture, you see also connectors and search services, and even the UI is part of the search domain because you have the user experience and so on. And you also have this business console, which is at the bottom, which is also important. But as I said, we will focus on specific OpenSearch features, and we will also show code around that. Was it? Yeah. So let's dig into it. A first feature that's not necessarily the most important one, but it's an interesting feature to have is the keyword marker. So you know that you have stemming, and you probably use it in e-commerce. You should use it because people will search in plural. Or will search like for leaf and leaves and mice and mouse and all that. So you have the stemmer, but maybe you have noticed there are some times where the stemmer does not behave correctly. So you need a keyword marker. For example, these examples are taken from French, but you obviously find this in any language, especially with brands. If you have words that are brands, you should not stem them. This is why you mark them. This example shows in French actually between Barbie, Gillette, and Lacroix, which are brands. You also have other names there that are stemmed as these brands if you don't do anything. So keyword marker. And the stemmer override is to sometimes correct what the stemmer does. So the stemmer is faster than the lemmatization and doesn't require a dictionary. So in e-commerce, you need additional speed, so you usually use a stemmer. I don't know if I have a demo on this. I will just switch to the DevTools here. So stemmer override. This is without stemmer. As you can see, these are some exceptions that do not work with the English stemmer. So leaves and leaf, which are not stemmed correctly, and mouse and mice, which are not stemmed correctly. Is that okay? Okay. And this is the stemmer override that will correct that. So this is done manually here, but you can also automate this, giving the logs that you have. Okay, so pretty nice feature. Let's go back to the. Okay, you also have a feature that's called the nested data type. So in e-commerce, you have this hierarchical model. You have products, and then you have SKUs or variants, it's nice to have this feature, which is the nested data type. I think the e-commerce use cases are those that use this feature. The reality is that this query and the aggregation, the nested aggregation, are slower, so even 10 times slower. You can use this; it's nice to have, but you also sometimes should not use it. So it's an example, and a counter example also in the same time. Yes. The example that we give here, so you see that the variants, the SKUs are objects. So we have an array of objects, and actually because Lucian is not hierarchical, Lucian will flatten the data. You will actually end up with sizes smashed together and colors smashed together, and results will pop up with combinations that you might not have in reality. So this is the problem with the nested structures, and this is why the nested data type exists.
So you could also have a document for each. So you can also have a document for each offer. So you don't have a document with a lot of variants, but you have a document per variant. And now I will show the function score query, which we like to call the Swiss Army knife of e-commerce queries, because it is very used in e-commerce, so it has a lot of benefits. Well, for example, we can use it to boost the score based on some attributes in our products. For example, here we will search in a movie index, and we will boost the products that have the most vote average and also have a lot of vote counts, so that we will give the better movies in the first positions. And I have a demo.
Just to say a few words on this example. Okay. I'll let you read the demo and then.
So we have a demo for that. For example, we will search for laptop in titles of products, and I will retrieve the title, the rating value, and categories. So if we do our request, we will have, for example, this one with three stars, or in the first position. It is very relevant, but it's not the best products to put in the first position for our clients. And we will have another products with a lot, which is much appreciated by the users. So we will have a function score, the query with a function score. So we will have the same query in it, and we will have multiple functions, for example. So this one is that we will boost based on the field rating value with the factors, and if it's missing, it's just if it don't have rating, so it's just one as a value.
So in e-commerce, the lexical relevance is not enough. Usually, you add some business criteria to the relevancy. Okay. And yeah, the function score is really the Swiss Army knife that allows you to do merchandising, allows you to do relevance, to tune the relevance, and so on.
Okay. So for example, we saw that with the rating value in the function score, we will have the same products, but we have better rating values in the first position, which is better for our users, and we also have the other product which was in the first position, but it's not really relevant for the user. So we use it for these needs, but we also have to handle the relevance, as my colleague said, because what is relevant in keyword is not very relevant for the users. And so we have also to add some boost, for example, for the ratings, but we also could use it for users preferences, or what we know about the user profile. We can also do it with vectors. For example, we vectorize the users' profiles, but we can also do simple things with the function score query. So for example, we can have a function queries, and we have the users. And in our products, we have an attribute that is liked by persona. So for example, if we are hard rock fans, or if we are vegans, we can, and we also have the user informations. So it's like the user is connected, and he has the tag, for example, or they have the tag for that they are vegan, or they purchase a lot of vegan products. So we can use also a function score for this.
You actually use a clusterization, so you place the products in clusters, and then you just enrich the user query with the user profile. So the user profile is also clusterized, so the user is tagged with clusters that they might be close to.
Yeah. Yes. And we have also the frequently bought items of a user. It's very benefit if we are in the case of e-commerce, but in alimentary, for example, so the user will come each week or each month to buy the same food that he buys every week or every month, or he buys, for example, some makeup furniture, so he will use mostly the same products each time. So we have this data, and we have the frequent bought item of the users. So we can use also function score to boost them in the first, not really the first position, but to boost them so that the users are very happy. So when they search for some items, they find that the product that they use are in the first position, and they will not search a lot for them.
Yes, function score. So really the Swiss Army knife. Yeah, we must talk also about auto-completion. in the e-commerce use cases. Yeah, I'll just take down. So first of all, there are things that you shouldn't do for auto-completion. So there is no like auto-completion feature with OpenSearch. It's not like you just check a checkbox and auto-completion is there. So you have all the tools to do it, and you can build a lot of things, but there's no such feature as auto-completion. It's not like you say, okay, I have OpenSearch, so auto-completion is free. I just activate it and it's free. Okay, and of course, when you say auto-completion, it's kind of vague because in reality, there are many types of auto-completions. In this screen, for example, I have at least 3 types of auto-completions. You can have even more, but we will not like go into details now. So the first one, which is the one with the products there, it's the simplest one. So the one that comes pretty out of the box by default. You just have to use Edge Ngram for that, which is a feature that Apache Lucene provides, and you have it available in OpenSearch. So the idea is, you just use settings in your index, and you define the Edge Ngram analyzer, and it works like this. So it will actually cut the input text at index time, and it will index it with tokens that comes from that. So the index is already prepared with what's needed at search time. And you also have the possibility to use a different analyzer at search time, and you have the use case that's kind of different. So still talking about auto-completion, you have highlighting. So people tend to highlight the results in auto-completion with JavaScript or stuff like that. You shouldn't do that because OpenSearch has a highlighter, which is very powerful. You can handle in JavaScript things like capitals and accents, for example, but you will not be able to handle, for example, synonyms or stemming or stuff like that, which the search engine already knows. And this is why for everything related to highlighting, you should send the query to OpenSearch and use the output that OpenSearch sends. Second use case for auto-completion is the one that's on the left there, categories, brands, stuff like that, which resemble to facets. So you could use aggregations. That's a feature in OpenSearch, but it's not the way to do it for an auto-completion, which should be really fast. Each character that you type will issue a query, so it has to be very fast. So you still use Edge Ngram, but on a specific index that you have to create separately. Okay, so it's not OpenSearch that will create it for you. Okay, and the third one is the most complex one. It's actually the first one, but I left it to the end because so it's the keywords one, where you actually provide suggestions of search terms. So the user starts typing, and you provide the suggestions of search terms or phrases following what they typed. So you have to provide meaningful keywords or meaningful phrases, and this is kind of complex, especially if your data is not structured. If you look at the titles, the product titles here, you see that they contain a lot of terms, and actually it's not something that you can display here. You cannot display like 16-inch and stuff like that here. Okay, so how do you do that? It's again not a feature that's just activable by default or something. You have to build around OpenSearch, and you use a technique. You could use machine learning also. There are models that will do that for you, but you can also use Apache Lucene analyzers to create shingles out of the unstructured text, then order these shingles and construct a index, a dictionary with these keywords there, and then use again a gengram to bring them up. Okay, we have a demo on this actually. So another feature that OpenSearch has out of the box is completion suggestion. So it's kind of like not necessarily difficult, but you have to do things to put that in place. You have to work on the mapping, you have to work on the index, the index document, you have to work on the query, but it kind of goes like this. So let me show it here. So we had the functions core. So yeah, imagine that the user like did some typos here and you want to display a did you mean functionality there. So it's pretty straightforward. You can just use this completion suggestion. So the query is really easy, but as I said, you have to be careful to also use the correct mapping and the correct input document. And OpenSearch will return the correct spelling and the suggestion of the phrase that you entered. Okay, so just you have to pay attention to some configurations there, but it works. Another feature that's very useful, it's the multiple search functionality. Which allows you, for example, for the screens, for this one, you have, as I said, 4 auto-completions in one screen. You will actually issue an mSearch query that will launch queries in parallel and will get the result in parallel. So you will, for this screen, for example, you will get the result much faster with mSearch. Yeah. And then another, I said 3, but actually I have another one, a 4th one, which is disambiguation in auto-completion. Again, OpenSearch doesn't provide that out of the box, but you can easily implement it like this. You have an update API that you can use to construct the dictionary for that, and you will just increase with the update API the number of occurrences, and then you get to this disambiguation stuff here. Actually, these are really explained in detail, and also other auto-completion use cases in this talk that we gave at MICES in Charlottesville. Okay, so yeah, this is the dictionary, these are the dictionary looks, and then the query that you issue on top of that in order to have this thing like disambiguation. Okay, so I talked about did you mean, and yeah, the things that you should take care of is the max error parameters that you see there, that it's in the query, and also the differences between term suggester and phrase suggester. Okay, another cool feature is the more like this query. So this comes out of the box. You have it already available by default with OpenSearch, and I think we have also a demo on that. So more like this. So imagine that you're like looking at this product here, which is a laptop backpack, and you want to display similar products to this one. Okay, you just have to issue a query like this that says more like this, and you give the ID of the product that you are targeting. You can also input here a fake document. You can use specific fields and so on, and you get results like this. So you see, so I was looking at the backpack, and yeah, you see other backpacks here, and so on. Yeah. So more like this query.
And there is also another feature in e-commerce that is very important. It's the empty result handling. So as we saw, because sometimes the user will write a query, but there is a typo in the query, or you have 0 result for this query. But you can use, for example, the term suggester or the phrase suggester to find the good form of the query if there is a typo, or if you change the query. The important here is to give feedback to the user, so that you say we didn't find the results for your query, but we find results for this query. So this is what, for example, for this example, we have, did you mean ergonomic chair of office chairs? Because we changed the input of the user. So it is very important that the user understand that you changed his query so that he will understand what he has in return. Yeah. And we have a demo for this. Okay.
The second.
Okay. Yes. So, for example, we talked about the term suggesters. We saw the example for the rubber bands. So, if I do the request with the typo here, we, for example, this is the code for our product, and we see that we have suggestions with rubber bands. It's the closest one for the typo, and we give return to the application, the front or the mobile applications, and we send the alternative text so that he will show it to the users and say, we didn't find the results for your query, but we changed the query, and now this is the query that we are using.
This is not a standard OpenSearch query, so it's taken from our plugin. So this is why you see _a2/search.
Yes.
It's not an underscore search. It's a typical query, but
it is usually
just so you can see the idea of rewriting a query.
Okay.
And the next example actually shows you how you can do it.
Yes. So it is using this functionality of suggesters to have the good query, and then we will put it in feedback for our users. And we have also another technique for zero results. So, for example, we will search for phrases or long text, and we want to be very precise. So all the words matters. So we should search for this phrase, and we should have products with all the words that are in the phrase. So, for example, we will launch a query, but we will have 0 results. So we want to show results for the user, so we will be less restrictive. So we will change the query. So it's a multi-match query. We will just change the type, for example, with the operator OR instead of AND. So, and we have the parameter that is very important, minimum should match, to say that, for example, if my query contains two terms, we should have the 2 terms in the products. But if it contains more than 2 terms, we should have, for example, if we have 3 terms in the query, we should have only 2 terms, and if it's 5, for example, 4. So if I launch the same query with these modifications, so I find
this minimum should match feature is really cool, and it's a compromise between and or. So and means all the words are important, all the words are mandatory. Or means any of the words that matches brings results, which is not so cool. If you have long phrases, then you use minimum should match, and this syntax allows you to say stuff like 2 words are mandatory, and then when I have a long text, 70% of words are mandatory. So 2 out of 3, 3 out of 5, and so on.
Yes. And it is also important in the first request, because if all the words are not mandatory, we will give good results, but we will also have too much noise. So when the user will use, for example, sorting, we will have a lot of accessories, for example, for a request, if he sorts by price, for example. So it's not very good to have a lot of noise in the requests.
Okay, just a few words about facets, and then we'll show a demo. Just e-commerce, so you have to talk about facets. There are plenty of things available there. You have aggregations, all types of aggregation, all sorts of aggregations that are available. We'll not dig into that. We will show just an example with post filters. But just if you want to see more, you can look at this talk at Haystack, and we kind of go through all that's possible with Apache Lucene and facets, and all this is available in OpenSearch. And you also have this talk here at MySys that goes even further with some other interesting stuff around facets. And just, yeah, we just wanted to show one feature around that, which is less known. Again, available out of the box in OpenSearch.
So for facets, we use a lot of aggregations and term aggregations, for example, for the checkbox in the UI. So for example, I will search for a laptop, and I have some hits here, and I have some facets. For example, for the facets category, I have electronics, and I have 35 products. And I will have also another facet that's called template, and I will have, for example, these 19 products for PC. When I filter on the category electronics, I want to filter my search results and the other facets, but I don't want to hide the other categories. So I want to keep them shown so that if I want to choose 2 or 3 categories, for example, I can do it. So for example, here we will filter on categories. So we see that we have our category that we choose, which is selected, but we also have other categories. So we filtered our results. We have less total hits here. I didn't show it in the first request. So I have 63. And when I filter, I have less results here, but I still have the same facets in categories. I just have electronics that is selected. But for the other facets template, it is filtered based on electronics. So I have less spaces here.
So the filter applies to results, to the other facets, but not to the facet itself. Yes. So this is the trick.
And to see how it works in OpenSearch, we'll see the request. So basically, this is our query. So to search for laptops. And we use post filters, so we will filter products, but we won't apply these filters to aggregations. So we'll always have all the data in aggregations. And we look at the aggregation sides. We will have the category, which is an aggregation, so a term aggregations on the field. So I have all my categories because I filtered on one. But in the other filters, I will have an aggregations for this field, but I have a filter aggregation on top of it, so that I will filter the other categories, but the one I choose will not be filtered. So I can add another categories in my filter. It's very useful for checkbox, for example, in web.
Yeah. Very quickly, a few words on synonyms and extensions. It's a very important feature in OpenSearch and for e-commerce in general. You have the synonym graph that you should use and plenty of stuff. We don't dig into that either. It's pretty straightforward, but there are some tips and tricks that you can take from this talk. And here's the summary, actually, and things like parameters, like auto-generate synonym phrase query option, and stuff like that. But yeah, what's to take away is that synonym graph is very powerful and it's available out of the box. It's available also by API and file and all that. We talked about marketplaces, which are, also we see them very often in e-commerce. And this is a query that's the Swiss Army knives of marketplaces, should I say, or yeah. Well, not necessarily, but it allows you to deduplicate results when you have the same product that comes from different vendors. Okay, so it's the collapse query that looks like this, and that can also give you inner hits with the results that come from each vendor. So you can display let's say the less expensive one, and then you say, okay, this product is also available in that place and that place and that place. Okay, and very quickly on this, so because we are approaching the end of the talk. We mentioned this business console here in the beginning, which is very important for an administrator. Usually an administrator is the one that handles the configuration of a search engine. And in e-commerce, the administrator, they handle also the merchandising and the relevancy and all the things there. Okay. So you have plenty of things that can be done. So these are not available by default in OpenSearch, but we are just listing what should be there in a business console. So maybe one day we will see them in OpenSearch dashboards. There is a screen that's really useful, and it's a beginning of a business console, which is nice. That looks like this. So remember the function score that we showed in the beginning that was boosting based on the rating value. So here's how you can compare results. So this one is without boosting, this one is with boosting, and you can see that the rating value 3.7 like went down 2 position, and the other ones went up because they are correct. They are rated for 4 stars, 5 stars, and yeah, so you can see the comparison here. So it's a beginning of a business console here, which is kind of nice. Okay, so yeah, things that we could have in OpenSearch, and maybe one day we'll have them. So things like this, so debugging, configuration, yeah, ensure the non-regression, and I introduced here Cupid, which is another tool that's available out there in open source, and that allows you to test the non-regression of your search engine. Very important, because in e-commerce you change the configuration very often, and you may have to make sure that you don't break anything. And I said that we will talk also about AI. Okay, so we couldn't do that without AI. There's just a few words about learning to rank. We'll have heard in this conference a few speakers talking about learning to rank, learning to boost, and all that. Well, we do think that in e-commerce learning to rank is not that relevant. So it's very relevant on use cases like Wikipedia. They are using learning to rank, and it's very useful there. But for e-commerce, the business user usually know better how to configure the search engine, so you don't need an AI to configure it automatically. But yeah, so getting back to AI, we don't have time to dig into all the features that you have there, but you have this talk at OpenSearch conference in Europe that's available on YouTube, and it goes through vector search and RAG with OpenSearch. Now, RAG to e-commerce, it's not necessarily the first use case. RAG is mostly with enterprise search, but you can use the same techniques for this. Okay, and last but not least, you know about the AI assistant that's available in OpenSearch dashboards. That's not necessarily very useful for e-commerce, except that, so it's a very nice feature. You can find a presentation here, but you do need in e-commerce a lot of monitoring. You monitoring the frequent searches, the zero result searches, the response times, so plenty of things. And actually the OpenSearch dashboards can help you with this monitoring, and with this context, the AI assistant is very useful. Okay, and otherwise, we also showed not a usage of an AI assistant, but an AI assistant for e-commerce that could be implemented at MySys this year. And again, you can look into that on YouTube. And that's it for our talk. We're happy to take questions.